All right, welcome to yet another not so entertaining but very educational video from Mr. Ewert's class. This is a grade 8 math lesson, and we are going into, I can't remember, let's look, 6.4, and this is about the distributive properties. So let's get into our whiteboard and erase what we did in a previous lesson. This is where my real fans on YouTube are like, oh my gosh, I watched the video where you did that. I feel so special on the inside joke. If you're a regular viewer of mine on YouTube, you have no life. So here we go. Oh my gosh, everyone in this room is a regular viewer of mine on YouTube. Oh, wow. This is a little awkward. Okay. So the distributive property, I'd like you to write this on your board and see if you remember how you could finish it. Boop, boop, ba-doop. Okay, so the distributive property, that means that 4 is going to affect everything. So everything in those parentheses is going to be affected by the 4. Bingo, bingo, bingo. Yeah, exactly. Exactly. Oh, no, I mean not exactly. No, I think the two of you forgot. We didn't have 8 divided by 2. We had 2 divided by 8. Okay. Nice. So I've got a few different things being written. A few people are going like this. A few people are going like that. Yeah. Yeah. But we're looking for the distributive property where it affects everything inside. But wait. This is a bad example. Oh. What does that stand for? What has to be done first? Parentheses have to be done first. But wait a minute. Let's now do it inversely. We got a different one, didn't we? So be careful. Don't forget your O. That's your order of operations. Now let's go into our samples. Gina's Trattoria Ristorante has only round tables. Each table seats 5 people. Some tables are in the lounge and some are in the patio. There are 20 tables in the lounge and 8 tables on the patio. Draw a diagram to show how to calculate the total number of people who can be seated. I'll pause here. Here we go. Okay, so we started talking about first what's a diagram. A lot of people thought we wanted numbers. No, this is a diagram. So we got the dining room and the patio, 20 tables in the dining room, 8 on the patio. It says there's 5 per. But now let's flip this. Whoops. No, we don't want to look at me. Then Gina removes some tables from the lounge. Use a variable to represent the numbers that remain and an algebraic expression. Now, first off, let's see if we can use a distributive property to represent this table. So I need something in the brackets. I need something here. I need some kind of things in these brackets. But there's a distributive property here. We have 20 tables somewhere plus 8 tables somewhere times 5 people at every table. So 5 times, because there's 5 at every table, got 8 somewhere, got 20 somewhere. Yes? Not everyone has 5 people at one table. Yes, it does. It says every table has 5 people. I agree with what you have. I agree with what you have. So I got 20 inside plus 8 outside times 5 at each table. Who had something pretty close to that? Could I have 8 plus 20 inside? Does it matter if it's 8 plus 20 or 20 plus 8? No. Okay. But now it says Gina removes some tables from the lounge. Some, but it doesn't say how many. So we now have an unknown. We have an unknown how many tables are in the dining room or the lounge, right? We know how many are on the patio. So before we had 5 times the dining room or the lounge and the patio. But now we no longer know the patio. And it says, write an algebraic expression for the number of people the restaurant can now seat. Can you complete it? Can you complete it now? We have a variable. Helga here in the front row has completed it.
Oh my.
Ooh, you have it different, and I like what you have too. I think that is also very smart. Very smart. Okay. This is cool. I saw this. So this is a formula where you can identify. So we have 5 times, I don't know, plus 5 times 8 on the patio, right? Okay. I also saw someone do this. I thought this was kind of cool. Check that out. That's pretty cool too. You know what I loved about this is I wasn't thinking about it that way. I was thinking about it the first way, but there was more than one way to do this formula, wasn't there? So hats off to you, person at the back. Let's see, what name should we call you? Gertrude?
Tinkerbell.
All right.
Tinkerbell.
Tinkerbell. I don't think so. Doesn't really, she doesn't have wings. Tinkerbell has wings. All right. So let's move on. Okay, we're looking for an expression. There's probably going to be a distributive property. A charity sells pots of flowers for $10 each to raise money. That's going to be like, what, 10 times something? 8 people pay with a $10 bill, 5 people pay with a $10 check. Total amount is, so let's come up with an equation first. I want an equation that shows the distributive property. I think you're close. You have some really good thinking there. I think you've got to rearrange your numbers slightly. Nope, I am wrong. Yeah, you're slightly off. You're close. I think you're bang on. Yes, I believe so. You'll see the error when we go over it. You'll see you're really close. You'll see you're really close. That would work too. Okay, so let's take a screen snap here. These are some of the things that I've seen out there. I saw, let's see, we had a charity sells $10 each to raise money. So I saw this. I saw that. So we have, because everyone's paying $10, right? 8 of them pay by check, 5 of them pay by money. Oh, the opposite. So would we get the right amount if we did it this way? That would work. Okay. Oops. This is interesting. I saw this. Does this one work?
No.
Would I get the same number? Because this one, I'm going to get 10 times 8 and 10 times 5, right? These two, same. The only difference is this one is using the distributive property. This is the same question, but it's expanded after the distributive property has been done. Oh, wrong frame. All right. Suppose you're selling event tickets for 20 bucks each. Some people pay with a $20 bill. Some people pay with a $20 check. Suppose B is the number of $20 bills you believe. C is the number of $20 checks you receive. Total amount of money you collected dollars is. Now, you have two variables. You have a B and a C for bill and check. We don't know how many bills, we don't know how many checks, but we do know that every bill is $20 and every check is $20. What do you think? But you don't have B or C in there, and we don't know B or C. I 100% agree, 100% agree. I 100% agree. I love that you had the expanded and the distributive. That was very wise. Very wise. Yes, you too. Right on. Okay. Now, some grade 7s are going, what? It's okay, grade 7s. This is a grade 8 concept. Oh, I like it. Okay. So one of the first things I saw out there was this. Oh, how's our time going? Oh, we're getting up there. I think we're almost done though, so we're cool. We're cool. Well, I'm not cool, but you know, you guys are. Here we go. I saw someone do B times 20 plus B, whoops, B, no, C times 20. Does that work?
Yeah.
Sure. What about this? Yeah. But now can you do it with the distributive property? Some of you had 20 times B plus C. These are all working same. The only difference is the bottom one is using the distributive property. So to distribute means to pass on between different people, right? And so you're affecting all equally. So the distributive property, whatever is outside of the parentheses, affects everything. I'm going to give you one quick example that came up on a quiz recently. I want you to rewrite this distributive property. Aha. So outside of the parentheses is a negative. That negative is going to affect everything inside the parentheses. Can you put the cup down so you can join us? If the cup is distracting you, you should eliminate it. And you rewrite this problem after the distributive property. Looks like negative times a negative and a negative times a positive. I can't quite see. No. Yes. Yes. Can you solve it? Yes. Yes, you got it. Yes. Okay. If I have negative times a negative, what happens? It becomes a positive? Okay, I'm going to help some of you who don't have it yet. So that became a positive 10 then, because negative times a negative? So I guess I don't need the parentheses anymore. So if the negative times a negative becomes a positive, what's a negative times a positive become?
Negative.
There you go. Who can finish this? Oh, not 50, 5. There you go. Who got it? Ooh, a couple of you. All right. That was the single most difficult example that I was going to give you. I think the rest of the examples, you can take a look here. Now, the grade 8s, we are now also talking about your distributive property in a model here. So this is the last thing we're going to cover. So with algebra tiles, here we have 4 equals x plus 5, or 4 times x plus 5. So you see x plus 5? You see how we had 4 of them? This is before. We had 4 groups, 4 times x plus 5. But you see how we just